So the focus of topic 4 is going to be simplifying algebraic expressions. In a previous video, we talked about evaluating algebraic expressions. So just a quick reminder, evaluating an algebraic expression is the process of replacing the variables with given values and then using the order of operations to simplify. So when you evaluate an algebraic expression, you're evaluating it down to just a single value. When you simplify an algebraic expression, you're not replacing the variables. So you're still going to have variables in your answer. Your answer is still going to be an algebraic expression, not just a single number, but we're just going to condense it down. It's kind of like taking crumbs on a table and brushing them into piles. So we want to take things that are similar and brush them into piles just to kind of condense it down. Okay? So a few definitions. Simplifying an expression is the process of combining like terms. So I could say combine like terms, or I could say simplify. I mean the same thing. And then like terms are terms that have matching variable factors. So this means same variables and exponents. Well, it'd be cool if I could spell exponents. So for example, x squared and 5x squared, those would be considered like terms. They have matching variable parts. A non-example, so an example that is not like terms, would be x squared and 5x. We have the same variable, but the variables are not raised to the same power. So unfortunately, these are not like terms. They can't be combined. Another non-example, let's say you had x squared y and xy squared. Well, here we have the same variables. We have the same exponents. We have exponents of 1 and 2, but the exponents are on the wrong variables. So though the exponents match and the variables match, they don't match consistently. So in the first term, the x is squared and the y is to the first power. In the second term, the x is to the first power and the y is squared. So those would not be considered like terms. The variable parts have to match exactly. Okay? Now, steps for combining like terms. First, you may have to apply the distributive property. So if there are parentheses, you need to get rid of them by applying the distributive property. And remember, the distributive property allows us to remove parentheses by multiplying through them, okay? Once you have applied the distributive property, if necessary, you then group like terms together, and then you add or subtract the coefficients of like terms, and then keep the variable factor the same, okay? So let's look at example 4. We'll look at the first part and then scroll down for the rest. Example 4 says simplify each expression. So when I look at part A, I notice right off the bat that I do not have any parentheses, so I don't have to worry about the distributive property here. And I do have different sets of like terms. I notice that I have x terms, and then I have, well, let's do green. And then I have constant terms, okay? So my x terms are like terms, my constant terms are like terms. So what I need to do now is just kind of group them together so that I can easily combine them. Now, the grouping together part is really helpful when you are first learning how to simplify algebraic expressions. Once you get really comfortable, you don't necessarily have to group them together, but just always use caution here, okay? So I want to write my 11x and my 18x together, but just notice 18x, we're subtracting it. So when I move it, I still need to subtract it. And then I've got my plus 3 and my minus 7, okay? So now I've got 11x minus 18x, so that's going to be negative 7x. So I just combine those two terms. I'm brushing those x crumbs together into a single pile. And then I've got 3 minus 7, which is negative 4. So I write it as minus 4. Again, I'm taking those constant crumbs and I'm brushing them into a single pile. Okay, so we're just kind of condensing our expression into something that's simpler. So the final answer here would be negative 7x minus 4. Okay? Now, for part B, we do have a set of parentheses, and we have one of those hidden. Let me get a different color. We have one of those hidden ones. So in front of that set of parentheses, we have the negative 1 that's in front of the 5x minus 8. So as we distribute, we want to be really careful, and we want to make sure we distribute a negative 1. So first, what I'm going to do is I'm going to drop down the 9x. I just want to go ahead and drop it down because I'm ready to add stuff to it, okay? And then I'm going to distribute my negative 1. So negative 1 times positive 5x is going to be negative. 1 times 5 is negative 5. All right. And then I just keep the x. And then negative 1 times negative 8 is going to be positive. So negative 1 times negative 8 is positive 8. In this case, I don't have to rearrange anything. My like terms are variable terms. And then I have my constant term. Okay. So I want to go ahead and combine my 9x minus 5x. So I would just take 9 minus 5, which is 4. And then I keep the x. And there's nothing to combine with my 8, so I just drop it down and leave it by itself. So that just remains a constant. So my final answer here would be 4x plus 8. All right, let's look at the last two examples here, or the last two parts of this example. So for part C, I have negative 2 times, in parentheses, 5x minus 6, minus 5 times, in parentheses, 3x plus 2. I have to distribute twice here, okay? Now you can show intermediate steps if you need to, or you can just kind of jump to it. I'm going to just sort of jump to it because we need to get really confident with this. Hopefully you've already practiced the distributive property. So I'm going to go ahead and say, okay, negative 2 times 5x is definitely going to be negative. Positive and a negative is negative. 2 times 5 is 10. And then I just want to keep the x, okay? Negative 2 times negative 6, I'm multiplying two negatives. That makes this a positive. And 2 times 6 is 12. I'm going to move to the next set of parentheses where I'm distributing a negative 5. So negative 5 times positive 3x is going to remain negative. So I'm going to write a minus. 5 times 3 is 15. And I just want to keep the x. And then finally, negative 5 times positive 2 is going to be negative. And it's going to be negative 5 times 2, which is 10. Now, if you need to rearrange these terms in order to kind of understand what you're doing, that's fine. We would just move the negative 10 and the negative 15x side by side, and then the 12 and the negative 10. All right. And so now I can see I've got negative 10x minus 15x. Those are like terms. So I take my negative 10, I subtract 15 more, which makes me negative 25, and then just keep the x. And then I've got 12 minus 10, which is 2. So the final simplified answer is negative 25x plus 2. All right, let's practice this one more time. So I have 3a minus 5 times parentheses 2a minus b plus 4 times parentheses a minus 9b. I will caution you, certain variables can be especially confusing. A's can sometimes look like zeros if you're not very clear with them. They can sometimes look like nines if you do too long of a tail. B's are really easy to confuse with sixes, so be really, really careful when you have those wacky variables. I generally stick with X's and Y's almost always just because they're easy and that's just what I like. But you can have really any letter of the alphabet. So just be careful with certain letters. Z's can look like twos. So just be cautious. Make sure you're very clear with what's your number, what's your variable. Okay. So I'm going to go ahead and drop down 3a. And then I'm going to distribute negative 5 through the first set of parentheses. So negative 5 times positive 2a is going to be negative. And it's going to be negative 5 times 2, which is 10. And then just keep the a. And then negative 5 times negative b is going to be positive, and I just want to write that as 5b. And then next, I'm going to distribute a positive 4. So positive 4 times a is just going to be positive 4a. And then 4 times negative 9b is going to be negative. 4 times 9 is 36, and then I want to keep the b. Okay, and now I want to group like terms. So I have 3 different types of terms that could potentially show up. I could have A terms, B terms, constant terms. In this particular instance, we only have A terms and B terms. We don't have to worry about a constant. So let's get all of the A terms together and all of the B terms together. So I have 3A minus 10A plus 4A plus 5B minus 36B. All right, so looking at the A's, I have 3 terms with an A. I want to take those coefficients and add them. So I'm going to start with 3 and 10. 3 minus 10 is negative 7. Negative 7 plus 4 is negative 3. Use a calculator if you're unsure on how 3 minus 10 plus 4 became -3, okay? And then we just want to keep the A. And then for the B terms, I've got 5B minus 36B, so I want to subtract 5 and 36. So 5 minus 36 is -31, and then I want to keep a B. So my final answer is -3A plus 31B. So when you're dealing with simplifying algebraic expressions, you're still going to have an algebraic expression at the end, which is a bit different than evaluating. Evaluating, you're replacing the variables with numbers, and it simplifies down to a single number. When you're simplifying, you're not getting rid of the variables, you're just kind of brushing up those crumbs. So you want all of your like term crumbs to be in a single term. All right, so make sure you understand how to evaluate and simplify algebraic expressions.